Okay, I'm going to continue on now. We have 6 more problems to go. Here it says solve for the indicated variable. They want to solve this equation for q. So I look at q, there's q. Even though there's another variable in there, I ignore that completely. Since there's only one q, I reverse order of operations, meaning I would get rid of the negative 4p, move that to the right hand side. By moving it over the equal, it's like adding 4p to both sides. And divide by 3 to get rid of q. You could divide each individual piece or the entire side, it makes no difference. So either you could say that's 4p over 3 minus 6 over 3, and that will be q equal 4p over 3 minus a 2. That's allowed. Or you could, if you wish, say, you know what, I don't want that. Q equal 4p minus 6 all over 3. This is an acceptable answer, and this is an acceptable answer. One is not more simplified than the other. Either of those will do. I look at number 18. They want me to solve for g. G, there's only one g in the problem right there. So I reverse order of operations. If there's anything added or subtracted, the force being added to it, I subtract that from both sides. 5 minus 4 is 1. And do you see that the 2k is being multiplied? I divide by the 2 and the k both sides. And I get g to equal 1 minus h divided by 2k. And that takes care of that problem. If I look at number 20, the first thing that I see is a fraction. This is over 1. The LCD for this problem is a 3. If I multiply the 1 by 3, now they both have it. Whatever you multiply the bottom with, you multiply the top with. A ratio of 1. It's an equation, so I ignore the denominator. This says 3r equals d into 60 minus t. Now you have two options at this stage. Most students will do this trick. They'll distribute the dn, not a problem, you could do that. 60 times d is 60d, and 6 times negative t is negative d times t. Remember what you're solving for. You want to isolate t by itself, this t. So, if I get rid of this, meaning move it to the other side, subtract the 60d, that becomes negative 60d equal negative dt. Since I want t by itself, I divide by whatever's being multiplied by it, and there it is. This is a fine answer. You really don't have to simplify any further. It would help just to put the negative up front instead of in the denominator. Mathematicians are fascinated by their denominator. Another way of doing this problem is for you at this stage to say, wait a minute, I see 3r equal d into 60 minus t. You would divide by d both sides. Most students don't do that, which is fine, that's not a problem. And to get t by itself, I would move t to the left hand side and this fraction to the right. The negative t becomes a positive t, 60 is where it is. By moving this to the right, that becomes negative 3r over d. No need to get a common denominator because once you get t by itself, you're done. And this is the next set of problems. Here I notice there are two fractions involved. Probably it's best for me to distribute this. Save me time. 2 times 7 is 14. 3 times 2 is 24. This is over 1 minus 2 times negative 4x is negative 8x. 3 times 1 is 3. And once you get the parentheses cleared, it would be very wise to find the LCD and proceed. The LCD in this case is 24 because 3 divides 24, 8 divides 24, and 24 divides 24. And the goal now is to make sure all of these are over 24. 3 times 8, Remember, whatever you multiply the bottom with, you multiply the top with, a ratio of 1. 8 times what gives me 24? A 3. And 8 times 3 will work. Since this is an equation, I would ignore the denominator. This reads 14 minus 8 times 8 is 64x. 3 times negative 5 is minus 15. And 3 times 3 is a 9. And you could use the LCD to clear any fraction and not deal with that. Combine like terms on each side. 14 minus 15 is negative 1 minus 64x equal a 9. Well, since I only have one variable, reverse order operations, add 1 to both sides. 9 plus 1 is a 10. Divide by negative 64. And I could reduce the top by a 2. Again, mathematicians don't like a negative in the denominator, so put it up front. Divide by 2. 10 divided by 2 is a 5, and 64 divided by 2 is 32. And that would be my final answer. I'm going to shift that a bit to the left, just to make it look nicer. There it is. Now, 26, the same deal. I see a fraction. The first thing that should come to your mind, besides, oh crap, where did this come from? LCD. A 7, 7 times 7, and 2 times 7. So 2 7s and a 2. That's 49 times 2. That's the LCD. What would this be missing to have the whole thing? This is 7 times 7 times 2. It has a 7. It's missing 7 times 2. It's missing a 14. Remember, whatever you multiply the bottom with, you multiply the top with. This second fraction has the 2 7s. It's missing a 2. And this last fraction has a 2 and a 7. It's missing a 7. And now I know that they all have the same denominator. I just read the top, ignoring this denominator altogether. So I have 14 into 4 minus 3x equals 2 times 2 plus 5x, and a 7 times negative x is minus 7x. Get rid of parentheses. This is 16, 40 plus 1, 56. This is 4 times 2 is 12, carry the 1, 3 plus 1 is 4x. Distribute the 2n. 2 times 2 is 4, plus 10x, minus 7x. Combine like terms on each side. 4, 10x minus 7x is a positive 3x. Move the smaller variable to the larger, add 42x to both sides. 3 plus 42, that's 45x. Subtract 4 from both sides. That will make this a 52 equal 45x. Divide by 45 both sides. X should equal 52 divided by 45. And that doesn't reduce. That's my final answer. 28. This is over 1. I noticed that the LCD for this problem, again, you could cross multiply if you wish. It's cx plus d. What do you multiply 1 with to make it cx plus d? Cx plus d. I don't like that d. And this already has it. Ignore the denominator. Oh, I forgot to multiply the top. Whatever you multiply the bottom with, you multiply the top with, a ratio of 1. So this says cx plus d times y equal ax plus b. Get rid of parentheses. cyx plus dy equals ax plus b. This is a bit on the challenging side. Remember, I am solving for x. My a looked like a 9. So, I see an x right there, and I see an x right there. I'm going to move this x to the left. I have cyx minus ax plus dy equal b. Move the terms that don't have an x to the other side. If you move the positive dy to the left, it becomes negative dy. And I noticed that x is common in both. I factor that out, reverse the distributive property. Out of the first, I have a cy. Out of the second, a minus a. And now that I have x times a quantity, I would simply divide by whatever this is both sides. I'll get b minus dy divided by cy minus a. Again, this is a bit on the odd part, but that's what it is. There's your homework, section 2.1 on page 82. You're going to do numbers 1 to 27 odd. You're going to skip number 21.